All right, so while we are waiting for the presentation and get it started, I can introduce you to our second speaker, who is Wendy Xiang. Wendy has been with TELUS for more than 6+ years working on software, data, and analytic projects, and most recently is leading a data science team as part of TELUS Accelerator team. She holds a bachelor degree of electrical engineering from the University of Toronto and Master of Management Analytics from Queen's University. Wendy is passionate about helping new graduates with career development and can be seen regularly in career fairs, hackathon, and mentorship program. So welcome, Wendy.
Good afternoon and good morning, everyone. I'm really happy to be here, and thank you for having me. So my name is Wendy, and I am a data science manager as part of the AI Accelerator team at TELUS. So before I get started into getting into a little bit of the AI use cases and applications here within the team, I just want to set some context on kind of what our team does and also how we apply AI. So when you first think about a telecommunications company or a company like TELUS, your initial thought might be, hey, it's telecom networks, 5G, network optimization and planning. So while we do a lot of that, and there's a lot of cool work in AI within that space, TELUS as a company really spans across multiple industries, and so does its application in AI. So in fact, some of the domains we'll talk about today and use cases, hopefully will surprise you a little bit. And we won't cover these today, but we also work on kind of some of the non-traditional domains that we're involved in. So to take some examples, finance, health, and agriculture. So how we've set up AI at TELUS is a little bit of a hybrid model. So we do have domain-specific AI teams that work on a particular portfolio or business problem. However, we do also have a central AI accelerator model. So this is the team that I'm in. And essentially how we work is we go across business units and business domains at TELUS, and we look for where there are high-value business problems that can be accelerated or enriched with data or with AI. And ultimately, we leverage end-to-end capabilities from the team. So we work with the business and our stakeholders, go all the way from defining the business problem, defining the AI problem and the AI approach, and then finally implementing and productionizing our AI insights. So it's really kind of an end-to-end capability and end-to-end approach, and that's why we get to see a variety of different use cases within the business. So without further ado, let me jump into some of the sample use cases. So I picked kind of 3 use cases from 3 separate domains today to hopefully give everyone here a view of maybe what are some of the practical AI applications might look like. Do keep in mind that this is a little bit simplified for today's conversation. So the first one that I want to cover is, I want to say, a little bit closer to a traditional AI application in this industry, and that is service analytics and customer experience. So the business problem here is that our wireless internet customers experience a lot of capacity issues. For those of you who don't know, wireless internet essentially is a service where customers access internet over the wireless network. In Canada, this is particularly relevant in rural communities where you don't have a fiber or copper connection. So as you can see, that's why they have a lot of capacity issues, because you're essentially trying to do everything on the internet, but over like a mobile phone connection. What we have noticed, though, as we look at the data as a team, is that even though some of our customers have capacity or network issues, it doesn't necessarily mean that they're having a bad customer experience. It doesn't necessarily mean that they're likely to complain. To explain this with a very simple example is that if you're someone who is just doing some light browsing, then having a slow internet might not affect you as much than if you were someone who is doing heavy gaming or heavy streaming. So the user behavior and the user experience actually matters a lot. So in order to tackle this problem, what the team did is really to build a predictive model that basically predicts what the customer experience of each of our subscribers might be based on a variety of network statistics, but also their past behavior of past tickets and complaints. The really interesting part here is that even if someone is having a bad experience, not everyone complains. So the model really helps to provide that comprehensive view and comprehensive prediction of what the customer is feeling like. Ultimately, how this is actually changing the business is that this insight gets provided to our call center agents who take these complaint calls, and they're able to get an idea of what the customer experience and a prescriptive action might be before the call even connects. As a result, we ended up seeing a 25% decrease in our average call handle times for these types of customers, and ultimately a better customer experience for our customers as well. Switching gears a little bit, I want to go to something that is totally different on the marketing side. So this is another product. So smart home security product is a relatively new product kind of in the company. And the idea here, the business problem is how do we increase smart home security adoption? So traditionally how a marketing campaign might work is a mass blast. So you would essentially send out an offer to everyone that you have a lead or a contact to. As you can imagine, this is not necessarily the most efficient way to run things. So one of the hypotheses that the team had is that crime rate, especially crime rate in a neighborhood, is positively correlated to a customer's willingness to buy smart home security. That's a hypothesis. We think it makes sense intuitively, but we wanted to actually test it out and ensure it actually works. So what the team did is we collected some external data around crime in different neighborhoods in Canada, and then ended up doing a series of A/B testing and campaigns to test out our hypothesis and also to adjust exactly when, how, and what neighborhoods to target. Ultimately, what we found is by really looking at the right triggers at the right time to connect with our customers, we're able to see a 2x increase in adoption rate of smart home security purchases. So this is really cool, and I wanted to bring up this example, which is that sometimes the applications of AI, especially in industry, doesn't have to be focused on the model. In this case, there's actually no model at all, but essentially is an insight that ended up making a difference. And don't get me wrong, we did actually try a whole bunch of models in this case, but ultimately it did not see the same lift as the insight alone. Covering another use case, again, in a slightly different domain. And I wanted to go back on an energy optimization use case in the data center. So as we're all aware of, large models are quickly becoming the hottest topic of last year and of this year. And with large models comes the requirement of large compute. So to really support all of that computational power, right, we need a lot of servers. And to have a lot of servers, we actually need to power those servers as well as cool these servers. So energy usage and consumption in data centers is actually a huge problem, as well as huge area of optimization for telecom companies today. So the business problem here is how do we decrease and optimize energy usage in our data centers? And here, what we ended up doing is actually an energy optimization system that is based on model-based reinforcement learning. And in fact, this is a research collaboration that we had with Vector Institute since a couple years ago, where the model as well as the initial proof of concept projects was developed together. So to go into a little bit detailed, what happens here specifically is an energy optimization system based on HVAC controls. So in particular, there's a mechanism called free cooling, where we are able to bring in outside cool air to cool the data center. So leveraging that passive energy instead of having to use active energy, in the form of electricity to cool your data centers and cool your servers. And by optimizing exactly when and how much to turn on free cooling, you're able to optimize your energy usage. And that is something the model agent was doing really, really well with. So ultimately, the end result is essentially a way for us to automate the control of our free cooling HVAC units in our data centers. And then, of course, what we estimated at the time was the first project was around 12% of annual reduction in energy savings in our data centers. And that is super cool because when you add that up, that is a lot of energy and also, a lot of cost as well. So these use cases might seem simple and relatively straightforward. However, the one point that I wanted to share with everyone today is that especially in applying AI, there are a lot of different roles as well as a lot of teams involved to actually make something happen. So in the data or the insight generation stage, right? So you have your core team, which is your data engineers, your data scientists, as well as your machine learning engineers. But you also, leverage help from external sources. So for example, we pull our data from a central enterprise GCP data hub, a cloud data hub, right? Where most of our features for the different models are being built from. And, in the cases of crime data, for example, we actually leverage external data vendors to bring and acquire external data that is then used to enrich the internal data that we have. So there's multiple players involved in that initial phase of looking at the data and then the insight creation. Of course, having the right insight is, only half of the story. The other half is really about how you leverage your AI and how you leverage your insight to actually make real business impact. And that's where some of the stakeholders come in from the business. So we work very closely with our business owners, with the execution team, looking after measurement and A/B testing, and of course, working with our privacy and security teams to ensure that there's proper use of the data as well. So it is actually a very big process as well to ensure that your data gets leveraged in the right way, as well as for you to get the maximum value out of your AI. Finally, to wrap up, I wanted to share kind of some of the lessons that we learned along the way of the past couple of years of applying AI within the organization. The number one thing is, as data scientists, sometimes we want to fit a model to everything, and we try to solve everything with AI. However, that's often not true. A lot of business problems can be solved with a process change or with a simple data or a simple dashboard. You don't need a model for everything. The second lesson that we learned is trying to look at model performance versus value. So a lot of the times, a model that performs at 90% versus 92% versus 95% doesn't actually make a huge difference. And almost always having a good model today is better than having a perfect model a year down the road. So that is, I think, something that we really learned, and it's the takeaway that we always keep in mind. And finally, I think I wanted to leave is that data science is hard. AI is not easy. A lot of projects fail and don't succeed. So knowing when to fail and knowing when to pull the trigger on that allows you to really capture the opportunity costs that you can spend elsewhere and ensure the overall success of AI within the portfolio, within the organization. So with that, I'll conclude my conversation. Thank you so much for spending the minutes to listen to me. And yeah, it would be lovely to hear and also share a little bit more of my story with everyone here.
Perfect. Thank you, Wendy. That was really informative. Such a nice use case, I would say. We do have one question from Sanket. He's asking if you can talk about business problem you're working on and not solved yet.
That's a very great question. I would say there are many of those. So to give everyone kind of idea, our current portfolio of essentially business problems as well as AI use cases is looking at about like 100 problems. So obviously not all of those 100 problems are able to be solved depending on many reasons. And most often it's actually a lack of data, right? So when we don't have enough data or don't have clean data to solve the business problem that we're looking at, right? That's usually what happens. So to give a really quick example, to go back into the call center, we had a business problem where our call center is noticing an increase in call rates for a specific segment of customer over their tenure. So when they were only in years 1 and 2, they did not call. And when they're in 3 and 4, they suddenly called in like a lot. So we looked at the data, we looked at different modeling, like up and forwards, back and front, and we couldn't find it. And ultimately what we realized was that it was a data quality issue.
Great. And we can take one more question. The question is, did you come across a project where using machine learning did not work?
For sure. Yeah. So I think this is kind of a slightly similar question, but I do want to kind of go back to the crime use case that I mentioned for smart home security. So like I mentioned, we did actually try modeling, right? So we tried to model which areas as well as which times people were more likely to buy smart home security. What we realized in that sense is based on the data we had, the time granularity was not enough for us to do, kind of a time series model, right? The model results simply was not good enough for us to make any informed decisions. And ultimately, that's why we decided to scratch the model and just go back to a pure insight and pure segmentation.
That's perfect. Again, thank you very much, Wendy, for your time and talking about the great presentation. And now we're gonna welcome back Jawad Ahmed for his presentation.